In this lesson, I show you how to connect a Node application to an Oracle database. With the database tables ready, it is time to replace the memory data source with a database one. First things first, open a terminal window, go where the project is located, and include the Oracle DB dependency using npm. But wait! Before you start typing the command, the Oracle dependency must not be added to the project descriptor because the Oracle Application Container Cloud Service provides you with the Oracle DB dependency as part of the runtime. If you add it and package it, you may encounter problems when deploying to the cloud. An easy way to do this is just to run npm install Oracle DB. Notice that there is no ---- save switch. This instructs npm to install the dependency, but do not add it to the package.json file. This is important so that the application has the dependency when you need it, but when you build it for the cloud, you can delete the node modules directory, run npm install, and you will be done. Don't worry if this is unclear. It will be discussed in further detail in the cloud-related lessons. After the Oracle DB driver is installed, it is time to modify the code. The first thing you need to do is set up the configuration required. Remember how applications set up the port variable to create HTTP servers? When you connect your application deployed in Application Container Cloud Service to Oracle Database Cloud Service, configuration values are provided inside environment variables. These variables are prefixed by the DBAAS string and contain all the information you need to connect to the database. In the configuration JavaScript file, I need to create another object to store the database-related configurations. To connect to an Oracle database, I need three things: the connection string, the user, and the password for the database. I create object attributes for each one, and using the same syntax for the port, I use environment variables to run on the cloud or default values to run locally. For the connection string, I use the DBAAS default connect descriptor environment variable or localhost/orcl string. For the username, I use the DBAAS user name environment variable or movie_usr, which is the user I created for the database. And for the password, I use the DBAAS user password environment variable or Oracle, which is the password for the user. Now, before I proceed, there is a change in my application architecture that I have to consider. Before, the data module was just a collection of functions. Now I want to create an object that provides me access to those functions, just like the controller. In the module, I expose a single function that returns an object that I use to interact with the database. And I particularly need this because of the need to access the configuration in all my methods. Also, since the database uses non-blocking input-output, instead of having the functions return the values from the database, I need to require a callback function as a parameter, and then when I have the data, call the function with the data. To demonstrate this, I already modified the in-memory, movie controller, and server.js file to use this new architecture. First, the server.js. There are minimal changes here. The important stuff, line 8, is that I create a data source object using the data.open method with the configuration parameter. This way, I construct a data source object using a configuration. Now, the in-memory file. It is mostly the same, at least the first part is. But, instead of having the getAll, get, add, update, and remove methods exported, I export only one method, which is the open function that is used in the server.js file. Inside, I create an object, and I will return this at the end of this function. This data source object has the getAll, get, add, update, and remove methods previously exported. Now, all of these methods receives an additional parameter, a callback function. At the end of the function, instead of returning the data, I simply call the callback function with the data. This emulates the non-blocking input-output, but the database version will use it to its full potential. Now, finally the controller. The change in the controller requires using the callback mechanism in the data layer instead of using the data directly from the function. So, in each of the calls, I send a function that will write the response using the data. Notice how the functions are practically the same? If I can create a common function, I could refactor this. And in fact, I can do that. To do so, I create a function that will return the callback function that I need. There, I send the response if there's data, or a 404 if there is no data. With this little refactor, the code now looks cleaner. Now that I have all the modules ready, I can create the database module. The file is going to be moviedb.js and is inside the data folder. First, I require the Oracle DB npm module. I set the autocommit in the required Oracle DB object to true. This makes all inserts, deletes, and updates immediate, not requiring a commit to actually store the data. Now, I must create and export the open function. This receives the configuration and returns a data source. Inside the data source object, I add the getAll, the get, add, update, and remove methods. All of them receive a callback function along its parameters. Time for the getAll function. To get data using the Oracle database driver, you need a connection, and then with the connection, you execute an SQL query. That sounds simple, but it has to use non-blocking input-output to get the connection and another one to do the query, so the code can get really complex really fast. First, to get the connection, you must provide the connection properties in an object. The object must have the user, password, and connection string for the database. You have all these properties already in the configuration. Using it is very straightforward. Now, to get the connection, call the getConnection method in Oracle DB. Provide the connection properties object and then a function that is going to be called when the connection is available. This function has two parameters, an error object and the connection object if successful. Inside that function, the first thing to do is to check the error object. If it exists, then there is no connection and the execution must stop. Log the error in the console using console.error. And since there is no data because there is no connection, this should be the end of the entire execution of the getAll method. So I can invoke the callback, empty, so the response finishes, and then a return statement to stop execution of this function. Now, if the connection is successful, I must do a query using the connection.execute method. The first parameter is the SQL query. Talking about SQL. This is the query that I used. It is a little complex, but this query generates the summary in the database, leveraging some work to it. I select all the movie columns, then I select the count of reviews for that particular movie, and then another select for the average of the score for all reviews of that movie. This query is quite complicated, but it will help you leverage some work to the database. The second parameter is an object or an array with the parameters used in the SQL query. The third object is an object with attributes for the call. For example, the attribute format Oracle DB object makes the query return an object for each row where the name of the attributes are the columns. And the fourth parameter is the function to call once the query is complete. This function has two parameters, an error object that works really similar to the previous function, and the result of the query. Inside that function, I must check the error object first. If there is an error, I must log it. Use the console error function, then close the connection. It is very important that when everything is done, you close the connection. Guess what? Closing the connection is also asynchronous and non-blocking. You could just invoke the release method, that's fine. But if you want to handle the error, you must provide a function. I could, for example, log that error. Then invoke the callback without any parameters, indicating that there was no data, and return at the end of the function. Now, if there is no error, I can construct the summary collection. Each of the rows of the result from the query are stored inside the result.rows array. I can use a for-each function to iterate each and push them into the summary array by creating objects with the attributes I need to return, and the values from each attribute comes from the database columns. Once I'm done with iterating the result rows, I must release the connection. Similarly, log if there's an error and then invoke the callback, but with the summary array this time. That was a long code, but it exemplifies how databases work with Node.js. A quick tip: try to minimize the number of queries you require to get the data you need, because each query will add another layer of callbacks to your code. If you require to make sequence queries, you will end up with a lot of nested functions. Nobody likes that. For example, to get a single movie, you need two sequential queries. The first one is to get the movie object. This is a simple select all from movies where the movie ID is equal to the ID of the parameter of the get function. Then another query to get all the reviews for that movie. Here you get multiple results and add each row to the reviews array inside the movie object. Then, only when you have the movie and the reviews, you may invoke the callback. Oh, but it gets even worse. The way I have the add, update, or remove function, I must return the movie that was added, updated, or deleted. To do this, I must add yet another layer to the get function. That will do the trick. You can imagine how this can get out of hand real fast. But yeah, for now, let's leave the code. Review the Oracle DB documentation. Try some simple samples with your database and the codebase from the movie application. You can create simple scripts to interact with the database without all the architecture complexities to focus on practicing just with the database. You just need to require the Oracle DB and then start invoking calls on the database directly. And yes, you can even use the REPL, but be advised that might be a little challenging. If the code seems hard to modify directly in the VM, you can install a JavaScript editor on the VM or on your machine and then copy-paste code and run it on the VM. When you're ready, go to the next video.